Hello, Mega Lab folks, and welcome back to the CAD tutorial series. My name is Russell. This is video 2. Hopefully you are here because you've already watched my first video, and if you haven't, you should go do that. Before we get started, open up your Onshape, and feel free to just pause this video and take a second to review the viewing controls. Remember, that's right-click to rotate, click with the mouse scroll wheel to pan, and scroll to zoom. Let's see. Yeah, if you want to, you can change those Onshape controls, the right click to rotate, etc. in settings, but I think they're pretty elegant in terms of, easiness of looking around. Let me know what you think about that. So we left off last time in Onshape with this, nice recognizable Lego brick design. This is cool and all. It's super recognizable, exactly what we expect a Lego brick to look like, but it's actually missing some really important features. These nubs on top don't really have anything to click into if the bottom of our brick is flat. It doesn't have anything going on. So we're going to model the geometry at the bottom of the brick, which is a little more complicated in this video. So let's bring up the drawing again, the drawing we were working from last time, and expand our view of this same document to show the bottom drawing. Here we go. So this is, as you can see, a more complicated, more numbers, much more geometry on the bottom of this thing. But don't get intimidated. We are going to use the same techniques that we used in the last video to make all this stuff. So first, before we get going, let's wrap our heads around what this drawing is actually talking about by taking a look at a picture of a real brick. And this can be a really useful tool, actually visualize the thing that you want to do instead of just, looking at it in 2D. So here's a real Lego brick. You can see that all this negative space here, this is, Lego bricks you think of as hollow usually, or mostly at least. These nubs that are on the side of the brick here, these are important, as are these circles, because, the top nubs sit in these little housings here. That's what causes the bricks to click together. So it's really important to get this exact sizing of those little housings correct, or the bricks won't click together. So that's what these measurements are all for. And that's what we're going to be modeling here. So how do we turn this, admittedly complex drawing into a model? I'm going to show one way in this video, and I'm just going to preface that way by saying that there are more efficient and frankly faster ways to do this. But I think it's important to learn this conceptual stuff from first principles. And I consider CAD first principles, as I mentioned last time, this idea of drawing in 2 dimensions and then sort of pushing and pulling pulling and then in turn pushing things into 3 dimensions. So I just want to start by using sort of the more simple, more intuitive ways of going about this. There are more advanced tools that these CAD softwares provide. And if you want to learn about those things, make your life easier if you're going to be doing actual 3D printing work, let me know you want more tutorials out of me, and or just email me if you got questions. My stuff's up. My contact info is on the door of the Mega Lab. I'm happy, friendly. We're willing to work with people to teach you anytime. But yeah, so let me know. Anyway, in the spirit of first principles and learning, we're going to use, as I said, the same principles of drawing in 2 dimensions. And then this time we're going to be pushing negative space out of our already existing solid object. Sort of the opposite of what we did last time of drawing in 2 dimensions and then pulling solid things into existence. So let's get rid of the drawing for a sec. And if you haven't already, use your right-click rotate to navigate to the bottom side of the Lego brick. Then we're going to go up here again, click the sketch tool, and then click on the bottom of the brick. We want to be sketching on the bottom of the brick. So we're in the sketch menu. Generally, my philosophy for complex geometry is to sort of start with the bigger stuff and then move to the more detailed stuff. So, in this example, that would be starting with the sort of border rectangle, and then I'm going to move to the nubs, and then I'm going to move to the circles in the middle. Remember, actually, if you remember from the picture, these little circles here are hollowed out of the inside of this. So we're actually not, if you think about, the sequence of pushing actions we're going to have to do, we're not at a point where we need to actually draw these circles yet. So for now, other than the fact that these mark the bottoms of the 8 nubs on top of the brick, we can ignore needing to actually draw these circles. They're just our sort of location guides. So back here in our sketch, we're going to sort of draw a generic rectangle and go into our dimension tool. The sketch told us that this wall here is 1.2 millimeters thick. So hit type 1.2, 1.2, 1.2, and 1.2. This is a primary area in which there are better tools for this, but simple is simple. So now we've got our shell, the outer rectangle that'll define our Lego brick wall. And now we want to go along in our drawing and draw each of these little nubs on the side of the, I'm overusing the word nubs, but whatever, on the side of the inside of the wall here. So these are small little squares that with the dimensions 0.3 millimeters by 0.6 millimeters. And their centers are lined up with the center of the top nubs, which, if you remember from up here, are 3.9 millimeters from the edge. So these are centered at 3.9 millimeters from here, and they are attached to the inside wall of the brick. So I'm going to go here, and we're going to hover along this line here, and you'll see actually, you see that little icon there, the 2 perpendicular lines. That indicates a constraint. When you click here, this is going to force this point to, this is called a coincident constraint, which means that the 2 points will be, basically the point you click on here is going to be forced to remain on this line. Basically, it's not going to, somehow float away from that. That becomes more relevant with more complex geometry, but this is an example of a constraint. So rectangle, we want this to be 0.6 wide and 0.3 tall. Now we can zoom in here and go to our dimension tool. And if maybe we go back here, the center of this needs to be 3.9 millimeters from the edge. But we can only really target these lines here to tell lines to be a certain distance apart using our dimension tool. So if the middle of this needs to be 3.9, then this edge is half the width of this, less than that. So this is going to be the distance from this midpoint to this edge here is 0.3. So this edge is thus going to be, little mental math, 3.6 millimeters away from the outer edge of the brick. Click back into here. Zoom in. This is going to be 3.6. That's in the right spot. Now we can go back and remember last time we used our pattern tool. We can go in here and click each of the, we want to pattern the whole nub, so individually click on all 3 of those lines. And we need 4 copies of it. And we need each copy to be 8 millimeters apart. So those are now, and now to finish that, we click off here. And those are now in the right spots. So same deal here. We're going to make a rectangle 0.6 by 0.3. And this has got to be, this line is again 3.6 from here. And we're going to go back to our pattern, extend this along here 4 times. And yeah, I know I'm going a little quick here, but feel free to pause, rewind, look at what I'm doing. Basically, I'm making each of these nubs by making a single nub, defining its location, and then I know how the interval at which they need to appear, using a pattern to extend them along the axis. So I'm going to do the same thing again for up here, except instead of 4 copies, I only need 2 copies. So this is now 0.3, 0.6, These are again 3.6 from the edge. And this one needs to go 8 millimeters down. So now to make them not go in this direction, we set this repeater to 1, and this one to 2, and this one to -8 to flip it down, and it's going to appear down here. So this nub is now down here. Same thing again over here, exactly the same process. Make a rectangle, a single instance of the object we want, and then have it be in the right spot, and then repeat it in the direction we want it to repeat. So this is again 3.6 millimeters, and we're going to pattern each of these. We've got to tell this to only make patterns in the vertical direction. And again, in the opposite direction. All right, so that's all of our nubs taken care of. This is a little messy right now. So what you can do with all these numbers if they get in your way, just drag them, get them out of your way. I don't want to see them. So I'm just going to pick them up, bring them out. And again, this is, as I mentioned before, a little bit of a messy way to do this. I will grant you that. But it's going to allow us to do this in a way that I think, in terms of the sort of what CAD is actually doing, it's going to make a lot more sense. So now that we've got our sort of outer things that are going to hold the things in place when the parts click together, we now want to move. Remember, looking at our drawing, we have each of these little tiny things on the outside here. These are all in place now. So now we want to make these circles in the middle. So this is 2 concentric circles, and they are over. So since these are 3.9 from the edge, and these are halfway between each of these, remember these are 8 millimeters apart. This is going to be 3.9 plus 4. 7.9 millimeters from the edge. Same thing from here. So these are centered at 7.9 millimeters from the edge, and these diameters are 4.8 and 6.513. So, can you quickly do that? Remember, we don't really care where this is, but we need a 4.8, and we need a 6.513. Escape to get out of the circle tool, drag these numbers around. And remember, we said with our dimension tool, these are going to be 7.9 away from the edge. That's from the left edge, and these are going to be 7.9 away from that edge. And then to finish, we are going to do the same thing as before, use our pattern tool, and make 3 of these 8 millimeters apart. Wonderful. So that is the negative space of everything we need to actually carve out of our Lego brick. So I'm just going to click check on this, exit this, and now we want to use our tool, our extrude tool, the same tool we use to pull this into existence, to carve regions out of our solid. So using the left mouse button, click each of the things you want to carve in sequence. So I want this main space here, and then the insides of each of these circles, and then up here to our extrude tool. So solid, and we want to, this has a bunch of different modes. We want to extrude a solid, but we want, instead of making a new solid, this is adding new stuff in that profile. We want to do the opposite. We want to take what's there and get rid of it. So we click to remove mode. And remember that this block was 9.6 millimeters tall. We want to keep our wall thickness 1.2, so 9.6 minus 1.2, 8.4 millimeters. Oh, turn my flex off. 8.4 millimeters. And that is, you can see the plane it's going to extrude that to. And so it's got that bottom bit there. So to finish this extrude, click the green check, and there you go. You got the hollowed out Lego brick. So you could 100% print this right now, but just to be complete and to show something, a little tiny thing, I'm just gonna, if we go back to our drawing, where are you? Here we go. I'm gonna add these little holes here, and these are centered under the holes up top, these holes here. So these are 3.9 millimeters again from the outer edge, this edge here. But when we sketch on this bottom plane, because you're only sketching on this surface here, and this surface doesn't know that there's a wall on the outside here. This contiguous surface here is the only thing you can draw things on. So that means that you can actually measure 3.9 millimeters to this outer wall. So if I draw a circle here that I want to be, that I want to be 2.6 millimeters in diameter. If I go to dimension this and tell it where to be, it's not going to let me, or is it? Oh, it is going to let me. Oh, that's new. That didn't used to do that. Okay, awesome. So I'm going to set that to 3.9. And same thing over here. Well, that makes my life easier. So same deal as up top. Linear pattern, select the circle, and do what we've been doing all along. 4 copies of this, 2 in this direction, and 8 millimeters spaced in each axis. Awesome. So we got our little holes, and if we go back to our sketch, these are 1.7 millimeters deep. So in our sketch, we are going to, again, go to our extrude tool, remove 1.7 millimeters. And you can see these little gray circles here are the new surface that it's going to create. And it's inside that nub up top. So finish that off, and there we go. We have a full, complete Lego brick. I know I sort of blazed through that there at the end. Totally 100%. I know I did that fast. Go back, rewatch it again, and let me know if you got questions about individual steps. I'm hoping that was clear. So yeah, this is, if Lego sent this out of their factory, this is what they send out of their factory. And what's awesome is that now that we've made this, we can print it. We can make our own. Sort of, we have full access to this as a shape that we can make things out of. This isn't super revolutionary because you can get Lego bricks, but if you think of a shape and you think a shape that's uniquely useful to your project, making it in CAD gives you full access manipulation capabilities to work with it in the world. So I'm going to do another video on actually printing things, but for now, hopefully that wraps up for the Lego brick geometry. Stay tuned for how to actually take this model and turn it into a real object. I'm going to do that tomorrow when I go to the Maker Lab. But yeah, if you've gotten here, congrats. That was your intro to CAD. You are now a pretty proficient 3D designer. We covered some really good skills there. And yeah, as I mentioned before, this could have been done simpler. I chose to do it in a somewhat messy way, I think, to show the concept of where we were starting from this flat surface and drawing the outline of this first negative space that we could push in a certain distance on a new surface that we create, draw the next layer of pushing and push that in turn. So I think conceptually that to me forms the foundation of what CAD is really doing, that you're drawing in 2 dimensions and then really yanking it or pushing it into that 3rd dimension. Yeah, so best of luck to you in doing this and in making your own shapes. I'm looking forward to hopefully meeting you guys, and we're helping you out with projects like this with these skills. Yeah. Now you go into the wilds of digital manufacturing. But yeah, have a good one.